Oh, thank you, Dimitri. Thank you, Dimitri. Yes, we're going to talk about 3D printing electronics today. First, I'd like to get an idea about the level of knowledge we have in the room. Can you tell me who's familiar with 3D printing? Yes. Okay, so we have a few people who never used it, I guess. Or who actually used 3D print so far? Okay. Cool, cool. So I'll tell first something about myself. I am Bart Meijer, co-owner of Rapperbuild.com. I have an IT background in software development, actually. I used to do Oracle software. And I also have a bit of electronical background in my study and as a hobby alongside my work the past few years. So around 6 years ago I started doing 3D printing. I built my own 3D printer. I'll show some pictures of what electronics I used back then. Around 5 years ago we started with Rapperbuild.com, which is our web shop. We do parts for the 3D printers. That's our main business as wholesale mostly. And we have a lot of end users like hobbyists and normal consumers who buy filaments. So that's our main market. Okay. What we're going to talk about today is I'll give you a little bit of an overview in 3D printing for the people who never used it before. And then we'll go into a bit of the detail on the history of the electronics so far. Then I'll talk a bit about new printers, new types of requirements they come with, how we are gonna, how I think we're gonna meet them, and so we'll have a little peek in the future of on the electronics and printing in general. So first, to elaborate a bit on what's a 3D printer. Actually, it is just a CNC device, like milling, drilling, laser cutting. It all has the same origins, and it has movement in certain directions, and it has a tool which can be used to produce or do something. In that regard, it's the same family of devices. So what makes a 3D printer special then? Well, we're using filament mostly to produce plastic parts, like our printer parts there, our logo. The filament is pushed through a feeder. We call that a cold end. It will be heated up to about 200, 250 degrees, depending on the type of filament. In a hot end. Then it becomes, obviously becomes liquid, yeah, thank you. And by placing that in layers onto a flat surface, you build a 3D printed part. That's how most, at least in the FDM, it's called the FDM technology, which is the kind we use in hobbyists mostly. So if you look at a 3D printer in a schematic view, to give you an overview on how the electronics work, we have in the middle a 3D controller board. I'll go into detail on what types of boards we have later on. For now it's just the 3D controller board. We need something to move, so we have stepper motors we need to control. We have some homing positions we need to know. So we use kind of end stops to detect when we're at a home position. We need a computer to control the printer. We need some power. The extruder is the component that's getting hot, so we need to have some temperature. And we need to have some temperature control by thermistor or thermocouple. And optionally, you can have an heater bed that will give you better results in situations that go too much in detail, but this is a general layout you will want to have for an FDM printer. So if we look to the process on how we print, first we have an idea, and we make that into a 3D model. So that's in your computer. We need to have that in a solid form coming out of the printer. To do that, the first step is slicing. So we'll cut the 3D model into layers, slices. And that's where the intelligence comes from. Is needed actually. The software that does that is the heart of the 3D printer. Without that software, the printer wouldn't do anything. The software translates it to movement, decodes. You can see that on the far right. And that just coordinates following a command. E1 is a command to move, and the coordinates after that tell the machine where to go. So from the model to the G-code is a translation the slicing software needs to do. And that involves a lot of CPU and memory consumption in the process, because you have to calculate the outer lines, the perimeters. You have to calculate the infill based on parameters the user can set, like layer height, speed settings. And this is also, it needs to be optimized for your printer. The G-code will mostly run only on your printer, and any printer that's exactly the same. If there are too much differences, your G-code will not produce the results you want. So that's very specific code for your printer. Whereas the model is a general file you can distribute, and other people can slice that for their own printer. Now that's something you have to understand about the process before we go into the electronics details. When we have the G-code commands, we want to translate it in actual movements, and that's the job of the electronics. That's what we're going to talk about today. The electronics are responsible for interpreting the G-code commands and translating that in movement. For example, if we want to move along the x-axis 100 millimeters, the G-command G1 will do that, and the controller board will control the stepper drivers to move 100 steps or 100 millimeter worth of steps along that axis. So this software that runs on this board, because there's a processor on the board who can interpret this, needs to have some knowledge about the printer. It needs to have knowledge about the temperature control. It has the logic to compensate for that. And it can interpret the G-codes. And this is very specific firmware, software, optimized for your printer. So far, this is clear. When we look at when I started actually, the first electronics I had was a Gen 3 electronics. I'll give you an overview about the history of the electronics. I'll go into detail on some of those later on. I just grouped them by type. So the first one is the general electronics we started using when then the rep community started building printers. So that was the first generation. The next generation was a bit more advanced. I grouped them together as the Tangdudu and the RAMs. And these electronics had a bit more compactness, more user-friendly, but it still was very technical to assemble and not really optimized for 3D printers. Later on, we got the Gen 6. That's probably the earliest single board solution there is out there. Well, we followed with the Mechatronics a few years later. Well, there's some alternatives, whereas this is a single board solution coming from the older more modular boards. And well, we're moving now towards higher processor power boards, more processor power, more memory boards, faster processing power. So that's the new generation. It started roughly in 2014 and will be coming with the ultrasonics, which I'll go into detail later on, of our own. And that will be released soon. To start off with the Generation 3 board. Well, the pro is it's very modular. Everything has its own module, which also makes it quite complicated. Sorry, yeah. I just checked the website, and on October 2015, the author of the smooth board claimed there was a new release coming. But after that, it's quite silent. So at this point, I'll go into detail later on how I see that. Okay? So it's a very modular board. Everything is its own module, which was necessary because at the time, this was my first electronics I used, and well, this was kind of electronics that could go up in smoke without some reason you could think of. So, well, mid-print, there might be a fume of smoke coming out, and you know you're in trouble. This was the level of electronics we used then. And we weren't thinking about printing for 24 hours. We were thinking about 2-hour prints. Like, well, I was happy when it was running 2 hours continuously.
That's a picture, right? That lets you know when it's done because it's smoking.
Yeah, exactly. The magic smoke tells you when it's ready.
Yeah, they don't do that now.
Not often. What was interesting is that the first printer started off with using a brushless motor for extruding. So it used run a motor to feed the filament. So it wasn't really exact. You couldn't know exactly how much filament you were extruding. So that was an interesting start to do that. So someone thought about, well, why don't we put a stepper motor as extruder? What's now common. But they used a hack to do that. H-bridge, they hacked to get the stepper motor working as extruder. That was controlled by software, so that was really flawed and caused a lot of troubles back then. But this was the best we got. Old-fashioned stepper drivers, not thermal protected, so if they heat it up, they will die. They won't shut down. So if you overcurrent them, you're killing your printer, which I had experience with, obviously.
Was there any retraction?
Oh, retraction we didn't know about them back then. This was just feeding filament and just be happy that it's coming out. That was the kind of phase we were in back then. At one point, someone designed the ramp, and the ramp was revolutionary in that it was more reliable. You can solder it yourself easily, the ramp board itself. It would go onto Arduino Mega, which was brand new back then. And it was, well, in comparison to the previous very modular design, it was a quite compact solution. And it proved very reliable compared to previous as well. Also, we have the new firmware. On the Gen 3, we had the 5D firmware, which was a hassle to work with. And the Sprinter firmware was the first firmware that really could cope with different electronics and had some nice features we didn't have before today back then, like retraction, etc. And become more advanced at the point. It became very popular. This board is still in production and being sold nowadays, so it's not really dead in that matter. But because of the popularity, there were a lot of clones, which meant that there were versions, mainly from China, where the fuses were of a bad quality. The fuse could just melt. The headers were of low current, so when you use the heater bed, everything become hot except for the heater bed. That kind of things were available for a reasonable price, though. But basically, there was a very big advancement in the hobby type of 3D printer. So after a while, well, we have the Gen 6 already on the market, but we decided as WebWorld that we would like to do our own board. The Mechatronics. This is version 1, so I'm very proud of it because it's the first real big electronics we did. And well, the advantages of that generation of boards was it was one board solution, which you didn't need the Mega, the RAMs, and all the step drivers. You just have a board with the Mega, Arduino Mega on board, the RAMs on board, SD card support, thermocouple support. You guys could start doing autonomous printing, just printing from SD cards without using a computer, which is a very good feature back then. And we did get modeling software. So you see a parallel between the electronics and software development, interchanging and helping each other get better all the time. When there was hardware that improved something, software would cope and get better. All the way around, if the software would have more features, there are becoming more boards that supported that features. Now, but six boards? Oh yeah, the stepper drivers are still modular. We also brought out the Minitronics 1 year later that has the stepper drivers on board. But having the stepper drivers modular is a design choice. We still do that with the new boards, and that has a great advantage if people can choose their own stepper drivers. Or they can leave them out and use external stepper drivers, which makes the onboard stepper drivers useless, which is just a lot of money you're wasting. So that's the design decision to still keep those boards separate. Yeah, you're right. Basically, there are solutions that provide one board for everything, and that's something people might prefer if they know what they want in step drivers. So we started really off with this board. After a while, we got feedback from customers. Dual extrusion became popular, so we needed more stepper drivers, 2 thermocouples, a better range of voltage support. This was, I think we did only 250 watts of the Mechatronics 1, and this started to become really popular. We sold around, I think, 3,000 to 5,000 watts right now. You will find this board in a lot of 3D printers nowadays. Looking at our new board, which I hoped to could show today. Well, I can show the prototype, but unfortunately it didn't release yet. I expect we can have the board available end of April, so in the coming few weeks we will release the board. So this is the new generation, I think, together with movie boards, older 32-bit boards. This has a bit of more processor power. I'll come back to that, why that's important, I think. It has 4 extruders, Ethernet support on the full edition. It's Arduino Duo based, so it's still compatible with all the Arduino software, mostly at least. And will support Rapture Monic Kimbra, which is also a new generation of electronics, more modular, better optimized. and supporting 32-bit software hardware. The current Marlin isn't able to do that because it's specifically written for the platform of the Arduino Mega.
I'm just going to make one point that one of the reasons for the torch is because I was complaining that we needed to have it compatible with the Kraken.
That is one reason you might want it. But I don't think the Kraken is a real good example for that. But color mixing might require more extruders, for example. If you want to extrude multiple colors at a time, that could be an interesting feature. That's why you might want to use 4 extruders. Next to the electronics boards, controller boards themselves, we also got more features, more upgrades. We started off with autonomous printing with just a SD card board and an LCD. And later on it became graphical LCDs. And now we are heading towards touch screens, AMOLED screens, one step bigger, more user-friendly designs sometimes. So also in the upgrade section, you'll see more improvements in that regard. Dual extrusion didn't hit off yet. I don't think it will hit off anytime soon because of inherent problems with printing with it, the complexity it adds. But color mixing, for example, might be a solution that's interesting in the coming few years to look at. And generally, the components we use are getting better. So we inductive sensors, better heater cartridges. We started off with nichrome wire. Then we got resistors. We overheated, overspec. And nowadays we are using heater cartridges, which are much more reliable and don't often cause fires anymore. So also in the components, you see a lot of improvements in the past few years. So if you look at the requirements for why are we bringing out Ultratronics, for example, why I think we need those features. We need more processing power, especially for the Delta printers. I'll go into detail on that in the next slide. The new technologies, which are actually new, but they become ready for hobbyists to access. I'll go into detail on that as well. There's a big trend in the market to go down in cost. 3 printers have come from 2,000 euros for a hobby printer when I started to around, we do 300 euros now for the cheapest printer. There are even cheaper ones available. So the electronics needs to support the low-cost, low-end market as well. I think we need smart software. I'll get back to that in a few slides as well. And I think integrated slicing will become a main part of the board in the next few years. Nowadays you can have a solution with a Raspberry Pi, which will do some slicing, but the processor power isn't really able to handle the requirements for slicing to do that efficiently. So I think we're going to do more boards that have more power and do onboard slicing in a few years, which also makes it user friendlier. Because the board can have more knowledge about itself, and you can have more profiles pre-made for the printers. So why do I think more processing power is necessary? We used to have only 3 axes, and every axis you did a few steps to move it. That didn't really require much stress on the CPU. These were just linear movements, so the processor just calculated how much steps do I need and what time, and it started stepping. With the introduction of the Delta printer types, which I have one over here from, These work differently. These type of printers have 3 stepper motors to control a linear movement. So if I want to move in the X direction, you can see there's 2 motors running at the same time. So for a movement, you can have already you can see that you have 3 motors running at the same time. Also, if you look at the movement itself, if you want to make a straight line, it's not a real straight line. The stepper motors, there needs to be a calculation on how much to move a stepper motor, to move it, without changing the height, for example. So there's a lot of computation power required for the CPU on board to calculate a path for the stepper motors to take to do a linear movement. And if you do high-speed movements on, sorry, thank you, it's all in here. Thank you. So that's something I think the new next generation of electronics support. If you look at the current generation of electronics, at the high speeds, you can see it becomes jerky, and you need to reduce speed to get good results from the print. And the new kind of electronics has more time to spare to calculate the movements, and the result will be that you can print faster without losing too much quality. So that's looking at the FDM side. Like I said, there will be in the coming few years, it becomes more accessible for hobbyists to get access to other types of 3D printing. We are currently betting on SLA. SLA printing is a resin that hardens out, for example, on the UV light. You can use a laser for that, but we are trying that with a projector, just a normal beamer, which produces a decent amount of UV light, which can harden out an image, can project an image onto the resin on the bottom. The resin gets hardens on the places where you shine the UV light on. And by doing that in layers, you can build a model like Eiffel Tower from top down. The advantage of that is that it reduces print time. You only need to enable the light for like 6 seconds a layer, as opposed to FDM, where you, if you have a decent print, you're running for a minute on one layer before you can go to the next one. So that could really improve your print time with SLA. The downside yet is that the resin is very expensive, and the technology isn't that easy to get feeling for. The first layers, you can't see anything in the resin itself. So if the print comes off, it will just float around while you think it's still printing. And after like 3 minutes, when the aluminum plate gets above the resin, you'll see that your print has failed. So that's things we need to solve and improve on before this can get mainstream, I think. Well, that's for the firmware, the controller board. It can be much easier and simpler because you don't have to calculate in paths for the 3D printer to take. You have just one Z-axis it's moving around, and that saves a lot of CPU power. Also, projecting an image takes far less consumption on the CPU and memory end than a toolpath calculation will do for slicing. This will reduce also memory and CPU consumption, making it more possible, plausible at least, to run on lower-end processors. An alternative, which might also be attractive is SLS, which uses a laser beam to harden out polymer. It melts polymer, becomes soft, glues together, and cools down, much like FDM, but then in a bath of polymer. Afterwards, you pull out the object, and you have a solid object. I think this is less likely to become mainstream for hobbyists, at least. Mainly because lasers are dangerous. You can do it wrong twice for each eye. So that's why I think it's unsafe for the most use in home. For the laser, yeah. You still have the tool path you need to run for the laser, exactly. A decent beamer can do HD nowadays, so you can project a quite good image on a resin bath, depending on how much you scale the image. The resolution will get lower or higher. But for a decent surface, it's quite easy to get a good resolution. For laser, you might argue you get even better resolutions. But then you'll hit the limit on the polymer, on how that will glue together, and get imperfections. But both technologies are still in development for hobbyists. There's no real solution yet. We are working on the SLA, like I said, and we're going to do something more the coming next few months with it. But still experimental, not as far as we have been come with FDM. Other thing I think we need to do for FDM at least is have smarter software. If we want to get 3D printing mainstream, hardware is one thing. We need bigger hardware to handle toolpath calculations better. But also we need a smarter software which is able to predict things in the design. If I want to print a tower nowadays, a big tower, I have to think about it before I slice it, because I need to adjust the temperature, it needs to be cooler, I need to enable cooling on time. So there are more requirements on the model than the current toolpath will calculate. If we make the slicing software smarter, so it will reduce speed at certain points in the print, or reduce temperature, then the software will be smarter, complexer, but it will be accessible for more people to use. So that's something we need to work on as a community to improve the next few years. Before we can actually make this mainstream technology everyone can use in our own living room. And I think that's still the goal I'd like to go. Okay, so far this is, I've talked about the electronics, the history of the electronics. I'll give you a bit of an insight on what we are doing. I think the general community is doing the next few times. I'd like to also tell you about the beer and pizza party. A lot of you are already familiar with it. Once a month we do the beer and pizza party at our shop. We can share ideas, thoughts about 3D printing with each other, ask questions. We are located in a Nooddorp, near the Hague. So it's about a 1.5 hour drive from here. And it's the first Thursday of the month, starting 6:30 in the evening. Oh, cool.
This Thursday, by the way,
this one.
is going to be a special one. We tried to do it last month, but the students weren't ready. We have a student team presenting the first that we know of, RepRap SLA printer, build your own SLA type printer. This is an introduction, and I think soon after that, the parts and all the components necessary to put one together yourself will be And the latest update we've gotten from that student team is that they've got the printer working and they're doing Eiffel Tower type of prints. And then the other printer that's being presented is a new Core XY design. Also, some of you have seen it. It's also by one of our regular attendees. He put together this design and he's gotten such fantastic results out of it that we're working with him to put that in the shop. And this is kind of the theme we're going here. It's an innovation center. People come with their designs. And the Beagle that Bart was showing you earlier and that we sell through the store now is also a presentation by one of our regular attendees, and we worked with him, modified it, customized it a little bit, and now it's for sale. So I think it's one of these environments. It's not just beer and pizza. It's a real opportunity to share ideas, learn from each other, and also when you come up with something that's fantastic, it's an opportunity to show it to the world, bring it to the market.
But don't forget, Bart makes the beer.
And Bart makes beer.
That's important. If there are no other questions, then I'd like to thank you for that.
Okay, thank you, Bart.